You're welcome to taptalks.com, and we are learning chemistry and basically organic chemistry. Now, we have reached a functional group. We cannot learn about organic chemistry without functional group. Because functional group is basically, it possesses the chemistry of the organic chemistry. The reactive part of organic chemistry is because of the functional groups. So therefore we can try to understand functional group as an atom or group of atoms that participate in chemical reactions of a given homologous series. Given homologous series. Now remember, the homologous series could be a very big thing, but out of that big thing there is always a functional group. And homologies, or members in the same functional group, members in the same homologous series will have the same functional group. So that functional group is the reactive part of the organic compounds or the homologous series. Yeah, it is really the reactive part of an organic compound. The reactive part of an organic compound is the functional groups. Is really the functional groups. Now we can look at the summary of functional groups that we studied in organic chemistry. There are quite many of them, but I want to list them and look at how their functional groups look. And by that so doing, we shall say we have really covered functional groups in organic chemistry. But of course, we shall not have to look at each one of them one by one until we complete all of them. And once we can complete these functional groups we are going to study here or discuss here, then we shall have covered the organic chemistry at this level. Summary. Summary of functional groups. We're going to subdivide it into three. This is the name of functional group. This is the functional group. Then this is the example of the functional group. example of the functional group. Now, of course, in organic chemistry, the first functional group we know is alkanes. Alkanes, and the functional group of alkanes is a carbon-to-carbon single bond. Carbon-to-carbon single bond, and an example is R. Now, this R could be alkyl group. Yeah, basically could be alkyl group or aryl. I'm putting this dash here to simply mean that there's a possibility of these arrows being the same or being different. So that should not really confuse my followers there. Another group is alkenes. Alkenes, the functional group in alkenes is carbon-to-carbon double bond. And when we're writing the carbon, the bonds, they should be entering this carbon and touching the other carbon because they are between the two. So therefore the example is, we can say we have a double bond here. Like that's an example of an alkene. An example of an alkene. Next, from alkenes, we shall have to study about alkynes. Alkynes, and alkynes have a functional group of carbon-to-carbon triple bond, and we can represent that by alkynes by that. Yeah, we are still looking at functional groups studied in organic chemistry. There are quite many, but so far we've looked at 3, and we are still progressing very well. From alkynes, we can go to alcohols, and phenols. Alcohols and phenols, they have a functional group of OH. Have a functional group of OH, and then we can represent them by R OH. Now, for phenols, basically, that R group for phenols, this R is benzene ring. That R is a benzene ring. Then for alcohols, this R is alkyl group. Yeah, that's it. Phenols will have R as a benzene ring, while alcohols will have R as an alkyl group. Now we have another set of compounds called the alkyl or aryl halides. Alkyl aryl halides. They have a general functional group which is dash X. Here I mean there is another compound bonded there. That's how it is. Now, for alkyl halides, this R is alkyl group. Alkyl group. Then for aryl halides, this R is a benzene ring. R is a benzene ring. Then from alkyl halides we'll go to ethers, and the functional group of ethers is dash functional group of ethers, and an example of ethers we could represent them like that. Now for this case, this R we don't mind. The R could be alkyl, the R could be aryl, whatever the case, but they will have oxygen in the middle of the R groups. Those are ethers. Those are ethers. Then from ethers, we go to aldehydes. Aldehydes have a functional group whereby for aldehydes, this is strictly hydrogen, not any other thing. But we don't mind whatever is there. Whatever is there is not an issue. But this is supposed to strictly be hydrogen. And an example of those aldehydes is the R. That's an example of aldehydes. Then from aldehydes, we shall go to ketones. Ketones. And functional group of ketones is that one. So for that case, whatever is this side could differ with the one which is the other side, or they could be the same. But generally, the example of a ketone is supposed to be this. Whereby these Rs could be the same or different, could be alkyls or aryl. That's not an issue. Now, collectively, these two are called carbonyl compounds. That's a collective name of aldehydes and ketones. They can be generalized together because even when you look at them, the functional group is almost the same. Apart from this one having a hydrogen, and this one does not have a what? Hydrogen. But they are normally all called carbonyl compounds. Now, from there we proceed and go to carboxylic acids. Acids and the functional group of carboxylic acids. That's the functional group of carboxylic acids. And an example is that's an example of carboxylic acids. Now, these carboxylic acids have derivatives like acid halides. Acid halides which have a functional group Rx, where this X is a halogen. And an example could be, that's an example of acid halides. They also have another called acid amide, another derivative, acid amides, and their functional group is that one. So we can say an example is R. Then another derivative is the acid anhydrides. And they have got a functional group and the example is R. Then from there we go to amines. Meaning before amines, esters. And esters have a functional group. And an example could be R, could be that. From amines, we go to amines. From esters, we go to amines, which have a functional group of that one. And an example could be that. Then from there, you can go to nitriles, which have a functional group. That one, and an example could be. Then finally, there is applied chemistry, and the applied chemistry does not have a specified functional group. So since we only look at functional groups, then we could stop here as far as functional groups are concerned.